I'm audible.
Yes, sir.
Am I audible?
Yes, sir.
In this class, we will study about how we can configure the pins for different functionalities. We know that since the number of pins available in the LPC2148 is only 64 pins, and it provides 45 general purpose IO pins, GPIO pins. They are classified into port 0 and port 1. Many times, to accommodate the different functions of the different blocks present inside the microcontroller like UART, SPI, I2C, GPIO pins are used for alternate functions. As we see the pins there, each of the general purpose pin, GPIO pin, has got three other alternate functions are there. We call as a first alternate, second alternate, and the third alternate function. For example, if you look at the pin 0.5, so it has got an alternate function, first alternate function with SPI, second alternate function with a timer block, third alternate function with an ADC. So I should decide as a programmer and interfacing engineer, I should decide I should use GPIO P0.5 for what purpose. So if I don't want to use as a GPIO pin, I can configure to first alternate, second alternate, and third alternate function. If I don't do anything, if I boot my system, that is if I start the LPC2148, by default, all the functionalities are configured for the GPIO, that is the 0th function. So if at all, if you want, after the booting, you want to configure them for the other alternate functions like a first, second, third, you have to do in the beginning of your program, the starting program, whatever you're going to execute, there you should configure for the required functions. So there are three registers are provided to do the job. They're called as a pin selection registers. So these pin selection registers are used to configure the pin select multiplexer, or what is called as a pin connect block. So every pin is configured by pin control block. The pin control block contains a pin select multiplexer. So by writing into the different bits of the pin selection registers, I can configure the pin select multiplexer of pin control block so that I can choose whatever the required function. So each of the pin can have 4 alternate functions are there. That is why 2 bits are required. So first 00 writing means the first function, 1, 2, 3 correspondingly choose the different alternate functions are there. So what we have to understand is pin selection 0 register is used to configure the general purpose IO pins P0.0 to P0.15. Pin selection 1 is used to configure 0.16 to 0.31. And pin selection 2 is used to configure the port 1 pins 0.16 to 0.31. So this we have to understand. Now we will start writing some programs to configure these pins, because before we develop any product, it is first and foremost requirement is you should take a decision what pin is used for what block. Am I using P0.16 for a different block or for a GPIO block? We should take a decision. So after taking a decision, I should be able to program accordingly. So the first program block which is to be executed as soon as you start your project is configuring the pin selection registers. So we will do now some programs on that. Now we will be writing programs. So in embedded C, we will be writing the program in embedded C now. So what I'll do is, so I will create a new project and then I'll start it so that you can able to understand them in a better way. So how do we start embedded C project? So I just close this project. I'll close this project. Now I will start the procedure. So now we will learn what is the procedure. What is the procedure we are going to use to create an embedded C project. Now go to the project. click the new Microvision project. So give the project name. Let's say I call this as an hardware project, hardware project 2021. So I just given, or a hardware project, I given the name. So then save. So now I'm creating a project in the required folder. It's very important. You create a folder of your own. In that folder only you have to create a project. Otherwise, a lot of files will be created. They'll be spread in that, in the D drive, C drive, or the desktop. Don't create the project on the desktop. Create a folder of your own. In that folder, you create a project. So now what I have to choose, since it belongs to the legacy chip. So then type the name LPC2148. So if the properly software is installed, legacy pack is installed, it recognizes the chip. I'll get LPC2148. Then say OK. Then here, unlike an assembly level project when we're doing it, so here's in the C project, a lot of initialization code has to be executed whenever the chip has to be started. The PLL has to be configured. All those things we don't require to do every time when we boot our system or when we write a program. That is can be taken care by a startup code which is supplied along with the Keil header file by the manufacturer. So let's include that file into the project. It's very important when you write embedded C programs, we will include them in the project. So I say yes. Now it already exists, overwrite. Okay, yes, I given it. So now you just go and check that in your source group, already one file is included. That is a startup.s provided by the manufacturer. Now I want to write my first C program. I want to create a program. So go to the file and say new. So before starting the code, I'll just save the program. So I can say it's a B section. Okay. So hardware. So let's see program. So program 1. I just given program 1, and very important, give it .c. Till now we were giving the extension as .asm. Now I given the extension as a .c program. I given it. Now I'll say OK. Now it's ready. Now the program 1 is ready. So I will include this program, whatever the C program, into the project. So go to the source group 1, add existing file. So include the C program and then add to the project. Now see that the program is included into this one. Now, as we start writing the program, so how do we write a program? So in a C program, we say integer main. So then we execute the logics what is required. As we know that last instruction in assembly, what were we writing? Yes, jump. So we were writing B. We in the assembly language, if you remember that, we were always writing the instruction like that. Skip, the B skip we are writing. That means that after executing all the logics, we keep executing indefinitely at the end of the program because there is no OS is there. So you have to do what? You have to repeatedly execute the last statement so that it will be there only in the code execution. So that microcontroller should not go to the memory areas where the code is not present. So you should not execute undefined code. So what we do it in the C, what is the same thing? I'll repeat that here by using while one. So it's like this I can write it, or I can just directly like this, like I can write it. Now this will be the last statement. So if it's previous to the while loop, if there's already indefinite loop is here, then this is not required. If there is no indefinite loop is here, it is always make sure that the last statement should be indefinite loop, so that you're not allowing the program to go to the logics which has not been written in the memory. Otherwise what will happen? It start executing all the junk code present in the memory, so unexpected results may happen. So this is the structure of our embedded C program. So whenever we write an embedded C program, as we know that there is a lot of hardware details of the microcontroller, I'll be using it to start implementing my logics. For example, I said in the beginning of the project, you should define what is the function of the each pin, for what purpose you're using the pin. Am I using a GPIO? Am I using for a timer? Am I using for a ADC, like that? For that, I said you have to use a pin selection registers. So what are the registers are there? Pin selection, 3 registers are there. So if I write, say, pin selection 0, correct now, if I write something value into this one, 0, 0 or something. So if you compile the program, see, I'll comment this one, I'll compile the program. Now, make sure that I will not get any error first. So it is compiling and there is no errors are there. Of course, one warning, let's not look into the warning. So that means the sense the structure of the program is perfectly right and the project is also properly created. Now I want to write into the pin selection register because I want to configure the pin. So what is the name of the pin selection register? As I already typed it, it's pin selection 0. Now I'll compile it. Now we'll see that do we get any error? It's giving an error. What is an error? It's saying that. So if you look at the error, it says that identifier pin selection 0 is undefined. That means that it cannot recognize. Am I audible?
Yes, sir.
So that is identifier pin selection 0 is not identifiable. This variable is not identified. So naturally what will happen, that is what the difference between the normal C program and embedded C program. I keep explaining the difference between normal C and embedded C program as I describe the topics. So the first difference between the normal C program and embedded C program is you should make sure that you are writing this C program for a particular hardware chip, the particular microcontroller. Since you are using a particular microcontroller, lot of registers what is present inside the microcontroller, I'll be using them to configure the chip before I start working it. To implement the different logics, I'll be programming the different blocks of the microcontroller, starting from ADC to the UART, GPIO, I'll be modifying it. So how does a normal C program can understand? No, I can include standard stdio.h or canio.h. Those will support only standard C functions. But none of the functions what is already provided as a part of a classic C libraries do not support the details of the microcontroller inside. So whenever you purchase a microcontroller, the manufacturer always supplies an header files corresponding to the microcontroller. So that header file you should include into a project. So what is the header file provided by the manufacturer? So I'll say hash include. So it is there in the header directory when you install the Keil. So there is a file, there is a directory called header file directory is there. In that, all these header files corresponding to different microcontrollers supported by the Keil are there. If it's not there, you can download from the system, copy into that header file, then you can use it. LPC2148. X I have used because so LPC214 family has got 214044 like that. Few chips are there. So, but I am interested in 2148, but 2148 supports all the chips in that family. So I have included that. If at all by chance it is not their header file for a particular micro, what you have to do? Copy that header file from their website of the microcontroller manufacturer, copy into the actually working directory. If you use a working directory, then use / that is double quote you use it. If you copy that header file into the header directory where Keil is installed, use these symbols. So now I'll just verify that whether does it work, because now I've included LPC2148 header file. What does this contains? This file, if you open and check it, you can open that. You can open and check that file. It contains all the names related to all the registers what is present in the different blocks of the microcontroller and their corresponding addresses. You should always remember that each of the microcontroller has provided so many registers. So these registers, whatever you have, which are there, these registers, whatever present, will have a unique address. If you look at this diagram, so this is a total memory address space of the microcontroller, that is LPC2148. LPC2148 provides how much of memory? Provides 2 to the power of 32. That is a 4 GB of memory it provides it. In this 4 GB of memory, so the first 512 bytes are used for your flash memory. It's used for flash memory. So that is 002, that's up to 512 kilobyte. You can address 32 bits are there, addresses up to 512 KB. It is meant for what? For the flash memory. So 32 kilobyte of SRAM is being provided in the chip. So which address start from what? 1 GB onwards is start. How do we calculate what addresses and how do you calculate? So I have just given one file. I can just share with you. So you can see that how you can calculate this one. I'll share this later. For example, so you can always share that memory map of RAM. So what is that? Totally 512 kilobyte is provided. 512 kilobyte means 2 to the power of 19. That means that 19 pins are required. So to generate an address for every memory location of 512 KB. So what is the starting address? Since it's starting from 00, I made everything 00. So this is the first address of the 512 KB memory. Then since the 19 pins are required totally, 2 to the power of 19, that is 18. The 19 means, so 0 to 18. So that means that when all these 0 to 18, 19 pins becomes 111, you are going to the what? Last address of the memory chip. So last address means remaining bits, I make it 00. Only the bits 0 to 18, I'll make it 11. So then I'll prepare a hexadecimal value for that, 0, 0. If somebody asks, what is the memory map of the ROM chip? Memory map means what? The range of addresses. What is the first address? What is the last address? This is called memory map of any chip. You should be able to know that one, because these are the valid addresses. Any address, if the ARM core generates other than this one, that means that memory will not be present there. So there's an exception will be raised, as we have studied. There's an exception will be, abort exception will be generated. So what is the memory map of the ROM? Since it's a 512 kilobyte are there, so 2 to the power of 19 is a 512 kilobyte. So even though 32 pins are there, only these pins will be used to access the different locations of the ROM. This is the address. Similarly, for the memory map of the RAM, what is the memory map of the RAM? Since it's a 32 kilobytes, and it starts from where? Not from 00. It starts from 1 GB onwards. So what is a 1 GB address? So this is the 1 GB address. So if you this is a memory location less than 1 GB. The next memory location is what? 1 GBth address. So we have used in assembly language 0x4000. We were using always. Why? 0x4000 refers to what? The first address at 1 GB. So this is the value. So I've just taken this one. So this is the address 010000. That is a 0x400. This is the address of 1 GBth location. From here onwards, how many locations are there? 32 kilobytes are required for the RAM. So how do you get a 32 kilobytes? 2 to the power of 15 is 32 kilobytes. So that means 15 lines. So 15 lines means 0 to 14 I've used. I made only those lines 1111 to find out the last address. Remaining lines I made it 000. So what I got? 0x400747 7FFF. So this is the memory map of the SRAM. So like this, I can able to find out what is the first address and the last address of the SRAM. What is the first address and the last address of the flash memory. So we know that. So by we know that 2 to the power of 10 is 1 KB, 2 to the power of 20 is 1 MB, 2 to the power of 30 1 GB. Yes or no? So like that, if you go and multiply, 2 to the power of 31 is 2 GB, 2 to the power of 32 is 4 GB. That is the total memory of this chip, whatever we are studying it. Now, so coming back to here, so I was explaining that, so these are the addresses allocated for the memory. Now, you have so many registers present inside the microcontroller, like pin selection registers, IO direction register, IO set register, IO clear register. Whenever I want to access those registers, yes or no, I should require an address for that. Because if these registers are not present inside the core, I should assume that when I say registers R0 to R15, only those are registers accessed present inside the core. Any other registers which are present inside the GPIO block or UART block, they are present what? Outside the core. These are the registers called programmable registers, which are provided by the manufacturer of the microcontroller, not by the manufacturer of the ARM. So these different programmable registers which are provided outside the core, but which is inside the microcontroller, are used to configure the working of different blocks. How do you access them? Since they are present outside the core, you should provide one address them to access this register. These addresses are provided as a part of the total 4 GB, as a part of the memory space itself. So total 0 to 4 GB, whatever provided, the memory map, which is generated by the address generated by the core. So this is nothing but what? This is the total possible addresses, because how many address lines are there? 32 address lines are there. This is the total possible addresses provided by the microcontroller. In these addresses, they have allocated certain addresses to the peripherals present inside the chip. Peripherals means nothing but what? The different blocks present inside, and inside the blocks, the registers are present. For them, they have allotted this one. So this is HP peripherals. I said there are 2 types of buses are there. Yes or no? 3 types are there: local bus, HP bus, and VPB or APB bus is available. So the peripherals or the blocks which are connected to VPB bus are called as APB peripherals. So the different peripherals present inside the different peripherals present, or the blocks which are present inside the microcontroller connected to the VPB, the bus, they contain the different registers. For those registers, they have allocate what addresses from 3.5 GB. So what is my intention to tell you is that is different registers present in the different peripherals of the block inside a microcontroller will be allocated an address. Those addresses will be starting from 3.5 GB. If I say pin selection 0, that means that pin selection 0 register is nothing but has got an address. That address between starts from where 3.5 GB onward they've allocated it. If you open the reference manual, you can download the reference manual of 2148. The reference manual or user manual of 2148, if you open that, they say that pin selection 0 is equivalent to one unique address. That address starting from this range. That means that, so every peripheral has got certain registers. Those registers has got certain addresses up there. So now coming back to our discussion here. So that means that when I say pin selection 0 register, it is nothing but what? For a programmer, it is an address, which is a predefined by the manufacturer of a microcontroller. So whenever I say pin selection 0, it's nothing but I'm referring what? One address. To that address, I'm writing the 00. So how do you, there are so many such registers, there are hundreds of such registers there. How do I remember the addresses? That is not possible. That is why header file will be used. So what is a header file contains? If you open that header file and see that they have defined as a pointer an address and they've given a name for that address. So header file is nothing but mapping of addresses to the names which were used in the program. That is what is an header file contains for a microcontroller. The moment I have a header file, that means that addresses of the registers has been given the names. Those names I'm using in the program. So this is the meaning of the including a header file into a program. Now pin selection 0. Now I'll compile the program. So if I see that it can recognize or not. If it does do not generate any error, that means that it is able to recognize this register. See that there's no error, so there only one warning is there. That means that I can able to recognize these registers inside a program. If it is giving an error, that means that what? You have not added a header file for that. Now, so now I got a program which do not generate an error. Now, what is my job? So we will start writing the program. So now we will set the different functions for the different pins of the ports now. That is the first example. So let's learn that. So now I take the first problem statement, set P0.5 to pin function 1, first alternate function. So I want to use the P0.5 not to the function 0. I want to use it for function 1. We know that P0.5 can be used for what functions? It can be used for P0.5 can be used for what? It can be used for so we know that P0.5 has got 4 functions there. I want to set for the first alternate function. So it has got a function 0, 1, 2, 3. I have to set for the first function. Now, how do we start the programming? Now, first identify the pin selection register and identify the bits corresponding to the pin. We know that pin selection 0 register correspond to what bits? 0.0 to 0.15. Pin selection 1 for these bits. Pin selection 2 for these bits. Now, since I'm interested in P0.5, so which register I have to choose? I have to choose the pin selection 0 register. So this is the register I have chosen now. Because why? P0.5 falls into this category. Now, after that, now what is the next thing I have to identify? In this pin selection register has got how many bits are there? There are 32 bits are there in that register. 0 to 31 bits are there. Now in this register, every 2 bits is used for what? One pin. For example, first 2 bits are used for what? P0.0. Next 2 bits are used for what? P0.1. Like that, I have to identify which are the bits now corresponding to P0.5. I said since 2 bits are required for every pin, multiply that into the 2. So which is the pin number you are interested? P0.5. Multiply the pin number you are interested into 2. So what you got? 10. So now go to the pin number. So the bits corresponding to the P0.5, these are the bits. What are the bits? So the bit 10 and the bit 11 are the 2 bits in the pin selection register 0, which corresponding to the P0.5. Now I have to program this one. What is the program? I can write into these bits either 00 or 01 or 10 or 11. I can write it. Now, what is my requirement? My requirement I have to set for the function 1. That means that I have to write 01 into this position. How do you write 01 into this position? See, first thing is whenever we write into any particular bits of a pin selection register, you have to follow number 1 rule. What is the rule? Do not disturb the other bits of the pin selection register, because other bits are being configured. You would have configured earlier in the program for a particular job, for a particular function of a different pins. Whenever when you are writing into these 2 bits, if you modify the other bits, what will happen? The functionality of the other pins is lost. The chip behave randomly. So it's very important. Only the bits corresponding to the pin of your interest you should be able to modify. Number one, that you have to remember it. Now, whenever you want to set this particular 2 bits to the required function, that is 01 or 1011, you do not know what is the earlier value. Earlier value can be 11, earlier value can be 01, earlier value can be 10. So just writing into these bits 01, or that is you just performing a logical OR operation onto these 2 bits will not give a proper result. First, what you have to make? You have to make these 2 bits is equal to what? 00. That is what you have to do. So first you have to make these 2 bits 00 without modifying the other bits. So what is the program logic for that? So the program logic for that, so look at that. So okay, so the program logic for that is, this is the job I'm doing it. So if you look at here, so I'll go to the, I think here, I think it's more clarity is there. So okay, so now I want to make only the pin. What is the pin now? What is the pin value now? So the pin value is the pin value. So let's say I'll declare an integer called pin. So equals, let's say now 5 in this case. So that means that the pin number P0.5 I have to set to the first alternate function. So what do I do it? So to get that particular bit number, I say 5 into 2. When I say 5 into 2, what do I get? I'll get a 10. That bit number 10 and 11 I'm interested. So the bit number 10 and 11, first you have to write what? 00 into that one. Yes or no? You have to write 00 into that one. How do you write 00 into that one? First I'll write 11 into that one. First I'll prepare a pattern. So say, look at that here. 0x3 I'll take it. 0x3 I'll take it. Left shift by 5 into 2. Now what will happen this one? That means that, so 0x33 is what? 11. So that means that 3 is nothing but 11. So 3 is nothing but 11. So I am taking the 11. So I am taking the 11. I am shifting into how many times left shifting? 10 times I'll be shifting. That means that if you observe this one, so that means that I'll be going to the position called 10 and 11, and there I am able to what? I'm moving the 11 into this position, and there I am able to what? Put 11 into that position. Come back here. Now, so I want to make only those 2 bits 00. That means that what operation I perform, we have learned in the assembly language programming, the required bits of any register, I can make it 00 by using what operation? AND operation. So whenever we perform an AND operation, what we do, the required bits we want to make it 0, you have to AND with a 0. All the remaining bits you have to make it 1. Now I'll prepare the whole of this value into invert. I'll invert the whole of this value. I'll invert the whole of this value by invert operation. Now, what do I get now? So first I prepared 1, 1. I placed 1, 1 exactly in the position called 10 and 11. Then I inverted the whole value. So then what do I got after that? So after that, what do I got it? Everywhere 1, 1, 1, 1, 1. Only in the position 10 and 11, 0, 0. And all 1, 1, I got it. That means that I'm able to generate 0, 0. I'm able to generate a number, 32-bit number, where the 0, 0 is located at the pin number, at the bit number 10 and 11. All the remaining bits are 1, 1. So now I have got a 32-bit number which exactly contain the pattern. When I AND that pattern with a pin selection register, only those 2 bits becomes what? 0. Now I'll AND with what? I'll AND with a pin selection 0 register, because that is a register I have to select it. Pin selection 0. So I'll perform AND operation equals. See, look at that. Now what I have done? I prepared a 32-bit pattern. So I made the corresponding bits which I make it to 0, 0, 0, 0. I'm just ANDing with the pin selection. Now those 2 bits become 0. So I've done the first job. So I've done the first job. So what is the first job? So this is my program. I've just taken this instruction. I'll execute it. This 2 bits becomes 0, 0. Now the second job I have to do it. So what is my second job? Now the required function, am I audible?
Yes.
So now what I have to do it? I have to go to those 2 bits Now set what is the value required, 0, 0, 0, 1, 1, 0, 1, 1, whatever the value required. Now, so again, how do you set the value? Now take the pin selection register 0. We know that whenever we want to set the value, what is the logical operation I'll use? I'll use the logical OR operation. Now, what is the value? I have to write it. Now, whichever the function you require. Now, for example, since the first alternate function, I take 0, 1. If you want to set to the second alternate function, write it 2. If you want to set it to the third alternate function, take 3, 3. So since the first alternate function, that is 0 and 1, first alternate function, I taken 1. So now, so you have got the pattern. So what is 0, 1 refers? So 0, 1 means, so 0x, 0, 1 means, so it is nothing but 0, 1. This is the function I have to set it. Now shift this bits to the exact position 10 and 11, 10 and 11. So that again, I'll multiply. So 5 into 2, I multiplied. So now I've multiplied that and placed here. Now look at here now. So what has happened here? Now I have prepared a 32-bit bit pattern, a mask. So where exactly the position 10 and 11 contains the 0, 1. So I prepared a 32-bit bit number. If you refer this number now, it looks like this. So exactly 0, 0, 0, 0. Only wherever required, you are writing what? 0, 1, again 0, 0, 0. That means that exactly at the 10 and 11, you made what? 0, 1 come here. So this is the pattern of the number what you generated from this operation. Now, after this is done, then what I have to do? Take this number, I have to logically OR with the pin selection 0 register. So that whenever I OR with this pattern, it will not modify any bits except the 10 and 11. I have done the job. So now these two instructions will able to configure the P0.5 to what? Required function. So this is what I indicated here. So what is that I have done? So this is the last instruction I have done it. After doing this operation, I got 0, 1 into this bit. So what is the procedure? First, identify which is a pin selection register. 0, 1, 2. Then identify the bits in the pin selection register by looking at the pin number. Then make those 2 bits is equal to 0, 0. Then OR with the what is the function you require, either 1, 2, or 3. This is the job we require to do it for every pin we are going to use in the LPC2148 for your project work. This always generally what we do, we execute in the beginning or put this in a separate function and call that function what is called as configure the pins in the beginning of our projects. So now we will see that whether does it work properly or not. So how do we look at it? So how do we use this program? Now I'll compile the program first. Now there's no errors are there. So there is no errors are there. Now I'll run this one. Now we will start learning how to use a simulator. See, till now your focus was there in assembly language and the registers and the flags. Now I'll never look at this. I can close this one. I will never look at the registers now. Since in the C language, it is not possible in the C language when you execute a program, look at the registers, what is happening, because it's not in your control. You're writing in a high level language that is converted into assembly statement that will be affecting the registers. I will not able to monitor them. I will not able to observe what is an equivalent of this instruction to the register. Nothing like that. I cannot observe it. So that is why. So the registered block of the project I'll not be using in the C language at all. I'll just close that. Always I'll be keeping the project here. Now my focus only in what? I'll be looking at the different blocks, what is present inside the microcontroller. In assembly, what was your concern? You're looking what is inside the core. Now when I write a C, I'm not looking at inside the core, but I look at inside the controller. This is what the difference. So when you write in assembly, your focus is what? Inside the core, what is happening, registers, flags, and everything. When you write a program in embedded C program to the microcontroller, my focus is what? Not inside the core. My focus is on the different blocks, what is present inside the microcontroller. How do you look at the different blocks, what is present inside the microcontroller? This is what is called as peripherals. These are the different peripherals, what is present inside the microcontroller. We have studied that when we studied the architecture, UART, I2C, SPI, timer, PWM, A2D, D2A, RTC, watchdog timer, GPIO, all these are the vector interconnect. These are the different blocks are present here. So as a programmer, as a systems level programmer, you should be able to know that how each of these blocks works, how each of these registers can be programmed. So that is the idea behind writing the embedded C programs and configuring the different blocks of the microcontroller. This is very essential whenever any company develops a product using a microcontroller. As I told you, there are thousands of companies are there, thousands of microcontrollers are there from every company. And the first thing what you have to do, somebody has to understand, somebody has to write these programs to configure the different one, then only the product development starts. So it's very essential for you as a computer science engineer to understand how the different blocks of a microcontroller are programmed and how you develop what is called as abstract functions, which can be used by an application engineer so to run to develop application programs. So when you write in Arduino, they would have provided a set of functions. So who has developed these functions? So inside, if you go and look at these functions, whatever used in Arduino, these functions contains these type of registers programming. So that is why, so once you know the microcontroller, you can develop your own functions, you can develop your own boards. You don't depend upon what is the boards available in the market. So you can always design the system on your own. So now we start using the blocks. What is the first block I'm going to use it? I'm going to use pin connect block. Pin connect block is the one block where I am able to configure the pins to the required functions. So it contains the multiplexes for every pin. So now I opened it. So this pin connect block, I'm choosing, because why I'm choosing pin connect block? This pin connect block contains the registers. Look at that, pin selection 0, pin selection 2, pin selection 1. There's already some ports are configured already. Who has configured this one? We have executed a startup S code. Yes or no? When we execute a startup S code, some configuration they would have already done. They would have disabled, enabled something they would have done. So let's not go into the details of that, what has been done. So we are interested in only what is we are using, what is the pins we are using and how to configure them. So now I'm using the pin connect block. Now these three registers are present inside the pin connect block. We will see that our logic has worked or not. Which is the pin I'm interested? I'm interested in P0.5 pin. So I'll go to the P0.5 and click on that. Now if I click on the pin 0.5, choose that what are the options are there. There are 4 functions are there, as we know that. GPIO port 0.5. So the SPI port, other is a timer port, other is a ADC pin. So these are the 4 options we studied also. So if I look at this block, you can just see that. So these are the pins. So if I look at P0.5, you can just see here. So these are the 4 alternate functions are there. The same thing is shown here also. Same thing, 4 alternate functions shown here. Now what is programming? If I don't do anything, see, I've executed the main program. I mean the first statement. By default, what? All the pins are GPU. See, all the pins have become GPU. Now, if I want to change P0 for the first alternate function, what is the first alternate function? That is configured as a pin of SPI block. Then I have to execute this statement. Let me see that. If I execute, if I written this code properly, then automatically P0.5 changes to that logic, that functionality. Let's see that. Execute the first statement, execute the second statement, I'll finish. See that now P0.5 has changed. So look at this P0.5 change. Here also it's changed. Automatically it is chosen to what function? It is chosen to the first alternate function. This is how you have to write a program to configure the functions of the different pins of the pin selection. So this is the first requirement your embedded C program. So now I will just change for other logic, 1 2 other logics I changed. So now it's stop. Let's say I want to change to the third alternate function. So if I want to change to the third alternate function, zero X.
Sir, we can't hear you, sir.
So your voice isn't clear. We can't hear.
Was I audible? Hello.
No, yes.
No, sir.
No. When I was disconnected, just now or what?
3 to 4 minutes.
So around 5 or 7 minutes ago.
What was I was telling last?
You were telling about function 3 and you disconnected.
Huh? What was the last statement I said? Can you tell me?
So like
Function-
changing the function, so function 3 or function 4, something like that.
So in
Function
the
3 you were
program, you were able to see the Keil program?
Not now.
Yes, sir. No, not now.
No, sir.
No. Keil program I was executing. No, that you have seen that?
That's
Yes, sir.
Yes, sir. Yes, sir.
two
No,
function.
Keil program I executed. No, that you have seen that?
Yes, sir. Yes,
Yes,
sir.
sir. Yes, sir.
So Keil program, whatever I executed, you've seen that, how to use that functions, and I've shown the pin control block that I've seen that.
Yes, sir.
Yes, sir.
Sure.
Yes, sir.
Yes, sir.
Okay. I think we can continue from tomorrow. I think from there we left. You can stop the recording.